Hello everyone. So today we are diving into 2D momentum. Whether you are a game developer or curious about physics, this video is for you. Momentum is defined as the product of mass into velocity. We have learned this before. So the two-dimensional momentum is when the object is colliding, but it's not colliding head on, it's colliding at a glancing. So you can visualize it here. So these two objects collide and then bounce back. Collide and then bounce back. This is called as a head-on collision. On the other hand, the glancing collision looks like this. When the object collides and they bounce back, not in the same direction but making some angle with the x-axis or y-axis. So the concept remains the same. We do apply law of conservation of momentum, but this time in both the directions, x and then y respectively. In one-dimensional moment, this is called as head-on collision, whether the first object collide with the secondary object and then the first object loses its momentum, the secondary object gains its momentum. In case of glancing, the object is not colliding head on, it's colliding at this point, and then object after the collision, the object move with a certain speed v, secondary object also move with the second speed the v1 or v2, and it's making certain angle theta 1 or theta 2. This is called as glancing collision or two-dimensional collision. In order to study this, we need to consider the total momentum in x direction must be equal to the total momentum in x direction. So we'll do it before collision and we'll do the same thing for after collision. So we'll separately conserve this momentum before and after in x direction and y direction as well. So we're going to write down for y direction as well. I'm going to write sum of its momentum in y direction before collision and sum of momentum in after collision must be the same. So in order to understand this, we need to know the resolution of a vector, since we know the momentum is a vector quantity. So when the vector is making an angle theta, you can resolve it into the two component. So let's watch this in an example. Here, this 4 kg object is moving with the 10 meters per second and it's colliding or heading on glancingly. So this is called as glancing collision or 2D collision, because as you can see after it, it's not going along the y-axis or x-axis. So this is a picture after collision. So if I could resolve this momentum after collision, 4 kg object moving the 5 meters per second, its vertical momentum will be in this direction and its horizontal momentum will be in this direction, which is making an angle 20. So the momentum of 4 kg object will be 20 cos 20 degree, while the vertical momentum gonna be 20 sine 20. This is just the component of it. Similarly, for 2 kg, I can split its component in x direction and y direction. So in x direction, its momentum to the right will be, since mass is 2 and then velocity is unknown, that's what I'm calculating, v and then theta. So its momentum will be 2v cos theta, and its vertical momentum will be the 2v sine theta. So in order to solve it, I'm going to equate the momentum before collision and after collision in x direction separately. So before this, the momentum is only in x direction. So I'll write down this sum of momentum in x direction must be equal to sum of momentum in x direction after collision and before collision. So if I work on this equation, the momentum of 4 kg object before collision is 4 into 10. The momentum of 2 kg object before it's 0 must equal to the momentum of 20. So this will be 20 cos 20 plus 2v cos theta. That's equation number 1. Similarly, I'll write on the momentum in y direction before and momentum in y direction after, and I'll get this equation over here. Since momentum of 4 kg and 2 kg before collision is 0, so I'll put it as 0, must equal to the momentum of 4 kg object after collision is 20 sine 20, and then the second object is minus 2v sine theta. So I have this equation number 2. So I'll be able to solve this. So I'll be able to write down the value of v, and I'll be able to get the value of theta as well. So using these two, you can calculate, since this is a two-dimensional equation or 2D equation, you can see the two simultaneous equations. You can solve for the value of v and then theta. Get this value and comment your answer. Next concept is impulse force time graph. So we know the fact that the force is rate of change of momentum, which is also known as mv minus mu upon t. So the impulse is basically the j, which is force into time. So if you talk about the unit for the impulse, since it's a change in momentum, so unit could be kilogram meters per second, or which is also known as like Newton's times seconds as well. So in the force times time graph, the area under the graph will be nothing but the impulse or the change in momentum. So if the ball is hit by the racket, then momentum of the ball changes. So there will be a force exerting on the ball, and if I plot this graph of force against the time graph, then it gives something like, let's say this. Then if I do calculate area under this graph, I'll get the impulse. So this is what the area under the graph will represent impulse or change in momentum. So similarly this as well, the third. So whenever this I do calculate area under the force versus time graph, that will tell me impulse, and that I'm going to equate it to mv minus mu to find out the velocity, or to find out the mass, depending upon what has been given. So in this example, consider in graph C, the force acts on a body of mass 3 kg initially at rest. Calculate the initial acceleration of the body, and then speed at 4 seconds and speed at 6 seconds. So in order to find the first initial acceleration of the body, as you can see, the graph it's the force which is varying with the time. So force is not constant over here. So the initial acceleration will be the initial force divided by the time, or divided by mass, my bad. So initial force will be this number, and if you read it, it's like 12 Newton. So that will be 12 Newton divided by the mass of the body is 3 kg, and hence I get 4 meters per second square. That's the initial acceleration. Then they're asking the speed of the body at 4 seconds. So at 4 seconds. So now I know the area under this first 4 seconds will give me the change in momentum.
One half. The base is like the 4 seconds, and the height is 12 Newton.
And this will be equal to the mv minus mu, the change in momentum. I knew it from the question that initial velocity is at 0, so the product gonna be 0. M, I know that it's like the mass of 3 kg, so 3 into the unknown velocity v. This gets 2, 24, so the v will be equal to 24 over 3, which is 8 meters per second. They ask you the speed after 6 seconds, so the 6 seconds is over here. We know in the first 4 seconds the total change in momentum was 24 Newton second. Last 2 seconds the momentum change will be negative. That will be 24 Newton second minus 6 Newton second. The total change in momentum will be 24 minus 6 is 18 Newton second, and then I'm going to equate it to mv minus mu, and now u is like 0. So now v will be equal to the 18 over 6, which is equal to 3 meters per second. The speed has been decreased because, as you can see, for the last 4 to 6 seconds the force has been negative, and negative force is a reason, or like it's like retarding force is a reason why the speed of the object gets lower. So this momentum is really useful concept in case of sports or in case of like car crashing. So I hope you understood this. That's it for today's. We'll see you in the next class. Thank you guys.